A 15 microcoulomb charge Q1 is at a distance of 20 millimeters from a 10 microcoulomb charge Q2. Both those charges are positive. Part I is calculate the resultant electrical field strength at M, the midpoint between the two charges. So if we jump across, that didn't work, let's try again, jump across the camera, there we go. So what we've got as a setup then is we've got 2 points. We've told the separation between them is 20 millimeters. So I should say 2-point charges. This one has a charge of 15 microcoulombs, and that has a charge. This one has a charge plus 10 microcoulombs. Now, these charges are going to be acting. Sorry, I should say first off, electrical field strength E is equal to 1 upon 4 pi E naught Q upon R squared. So that's the equation we're going to be applying. So if I've got a charge here, let's take an example of positive charge. This this charge is going to be pushing it in that direction. This charge is going to be pushing it in that direction. So you can see these electrical fields are opposing each other. Therefore, what we're going to be doing is subtracting them to find the overall field strength, because they'll effectively be cancelling each other out, or parts of each other out. So my overall electrical field strength is 1 upon 4 pi E naught, 15 times 10 to the minus 6, divided by, now it's at the midpoint M they're interested in, so that's 10 millimeters away, or 1 centimeter. So I've got 0.01 squared as the separation, and I'm going to have to subtract 1 upon 4 pi E naught, 10 times 10 to the minus 6 upon 0.01 squared. To make it slightly easier in the calculator, I'm going to take out the common factors. So I've got 1 upon 4 pi E naught times by 0.01 squared, and that's going to give me 15 times 10 to the minus 6 minus 10 times 10 to the minus 6, which will give me 5 times 10 to the minus 6 all over 4 pi E naught. Now E naught is going to be 8.85 times 10 to the minus 12 and 0.01 squared still. Then I've got to put that in my calculator. So, grabbing the calculator, I just get the bottom first. So I've got 4 times pi times by 8.85 e to the minus 12 times by 0.01 squaring the 0.01 squared. Then to the top divided by that answer. So I've got 5e to the minus 6 divided by that answer gives me, use the ENG button, I've got 449.59 times 10 to the 6. If I look at this, I've got 20 millimeters. I've basically got 2 significant figures, so I'm going to be writing that as actually 450 times 10 to the 6 volts per meter, and that's going to be 2 significant figures. Alright, so part 2 then. If I jump back to the question. A part 2, so we've got the same charges. Now at the point P, along the line between Q1 and Q2, which is 25 millimeters from Q1 and 45 millimeters from Q2. So the first thing I'm going to have to do is actually draw that out and figure out what is going on. So once again, I've got 2-point charges, and I've got my point charge 1, point charge 2, and I know these are 20 millimeters apart. And this is 15 times 10 to the minus 6 coulombs, and this is 10 times 10 to the minus 6 coulombs. Now, they actually want the point P that's 45 millimeters away from this one, 25 millimeters away from this one. So to do that, it must be 25 millimeters, and the point P I'm interested in then is over here. So it's 45 millimeters from there, 25 millimeters from there. Now if you imagine it, if I put a positive charge here, this is going to be pushing away, this one's going to be pushing away. So this time the electrical fields are actually additive. But we've still got the same equation, 1 upon 4 pi E naught Q upon R squared. So, same setup. My overall electrical field strength is going to be 1 upon 4 pi E naught. I'm just going to pull this out to start with. So I've got the effect of this one first, which is 15 times 10 to the minus 6 upon 25 millimeters. So I've got 0.025 squared. And I'm going to add on the effect of this one. So that's going to be 45 millimeters away, and it's 10 times 10 to the minus 6 coulombs. Divide that by 0.045, and I'm squaring that up. So, putting these into a calculator then is going to take a little bit of effort. Let's do this bit first. So I've got 15e to the minus 6 divided by 0.025 squared. And I've got to add on 10e to the minus 6 divided by 0.045 squared. So that's giving me that term. Then I've got to multiply by 1. So then I've got to do, that is all going to be divided by 4 times shift pi times by 8.85e to the minus 12 for the permittivity of free space. Gives me an answer, hit the end button, of 260.2073 times 10 to the 6 volts per meter. Two significant figures everywhere, so basically I'm just going to be going just 260 times 10 to the 6 volts per meter. Now overall this is going to be away, so the direction here should be away from Q1 and Q2. In terms of a direction here, because it's going to be, this would be combined effect. I should have actually said up here that the effect here is going to be, so this is bigger, so it's going to be away from Q1 because the field from Q1 is going to overpower that of Q2. Overall then, thank you very much.